Welcome back, everyone. Do not forget, you have homework. You're working in your assignment. Any question regarding the assignment, please let us know. Okay, I have a question in the chat. Yes, number one, I have some questions regarding this for your assignment. When you have a point and that point reach 5 connections, what you do is, number one, to delete the dot that have the 5 connections. So for instance, here you will delete this dot. So that dot is deleted, remove it. And also all the connections of that dot. So you will remove 1, 2, 3, 4, 5 connections. So you delete the dot first, and then you delete all the connections, the 5 connections that dot used to have. The other dots, the one in the screen, you do not remove those. Those dots are going to be there. Now, the next step, recalculate, is to find connections for those dots. So similar to the original approach, you are going to connect the closest dots to the others that exist. And the other question, you cannot have like something like this, 2 graphs. It should be 1 graph always. So all the dots should be some way connected with the rest. So if you have something like this, well, assuming that this is your graph and you delete this dot because have 5 connections, but then you have this, probably what you're going to do is to connect the closest ones. I don't know, maybe these 2, and maybe this, maybe this, maybe this, and the closest one to this point will be maybe this one. So at the end, you're going to have something like that. Again, you're calculating the distances, and the shortest distance, that is going to be the one that is going to create a new line. Good? Yeah, same idea. I mean, for instance, assuming that this one had before like 4 connections, and then just because this was the shortest path, you make this connection, and that connection somehow creates the 5. So the process repeats like recursively. That means just because you recalculate, now this had 5, so this one is going to be deleted. These lines are going to be deleted, including that one. So you're going to have something like this. And recalculate. And when you do the recalculate, I don't know, maybe now you're going to connect this one or this one, and probably this one again. But now it's not 5 connections, so it's going to look something like that. Good? Yes, the other question, remember, the idea here is you have the view. The view is the one that is showing you this, but all the process is happening in the model. Here in the model, you have a lot of classes that basically are working with a data structure. This idea of your repository with dots and lines, and here you are doing the calculations. And at the end, when these calculations finish, somehow this guy is going to draw the result. So separation of concerns, 2 different parts of the software. One finish, notify the other, and you have a result on the screen. Something like this. Yeah, the nearest point. Well, there are several different ways in which you can find the nearest point. You can use brute force. Brute force, basically, for every single dot, calculate the distance with all the other points, and you select the minimum. That is one option. People describe several different others in the previous lecture. Dijkstra. Again, up to you, your knowledge of computer science. If you apply brute force, that means 2 loops and searching for the short path. That is fine. But if you do that, you need to consider threads runable because it's going to be slow. So you need to have a thread running that slow process. The difference between using threading or not is all about if you have a fast process to calculate the nearest neighbor or not. If you do not have a good process for that, if you're doing something like I described, 2 for loops, searching for the shortest path from one point to all the others, probably you will need a thread because it's going to be a slow process and it's going to be something that you notice when you're interacting with the graphical user interface. I am not asking you to do mandatory the multi-threading. However, if you do not implement a good algorithm for the shortest path, you need multi-threading because this thread is going to be slow and the graphical user interface need to do something while this one is working. You never have a disconnect graph. And the decision to connect them, as I described, always the shortest path. That is the decision. Good. My advice, if you can provide an example, we can work example, but is use the shortest path.
Hello, Professor.
Hello.
Yeah, like on the right side, on the left side, like the points were disconnected. So like you drew that kind of pentagon, but afterwards, like on the right side, it was a separate disconnected graph. So like all the points on the left side were connected to the shortest, like the closest point. The right side were also connected to the closest point. But there is a line between, like which is connecting both of those graphs. So like what criteria must be used to join those lines, like join these two graphs, I'm saying.
The shortest path always.
Okay, like between the graphs also there should be a shortest, like whatever is the shortest path we should join with that.
Yep.
Okay.
Yeah, if for some reason, like in my example before, I don't know, you have all these guys here connected and suddenly you have, because this dot reach 5 connections, so you have these dots here that usually were connected with this one, but you delete that one. So in some point you have something like this. So that one is connected and all these dots are just disconnected. What you're going to do is to start searching for the shortest path. And what you can do is, well, the shortest path of this one, or this one with the graph. So I don't know, probably the shortest one is this one. So now these are connected with the first dot, and then you look for the shortest path, the next one that you can have. So this one, distances, this one, distances, this one, distances, and you're going to find that, well, the shortest path is this one. So that one is also connected. Now you have two, the shortest path there. Maybe it's going to be this one. You have only one, so the shortest path with this one, here or there, here, everything is connected. So again, there is no way that you end with two different graphs because you're always looking to connect the new dot with the graph that you already have. And when you delete one, what you have is 5, like 5 new. And what you're going to do is the same process. For each of those 5, try to connect with the graph that you already have. And you can start with the shortest one, and then with the next one, and the next one, and the next one, until everything is connected. Make sense?
Professor,
Yeah.
quick question. I just want to make sure I understand right. So you've got like that square they've kind of drawn on the screen right now. If a dot was added in the middle of that square, would this create like try and create like a minimum spanning tree, and all 4 of those dots would connect to the middle one then because it's closer, or only whichever dot of the 4 is closest to that new dot get a line?
Yeah, only one connection. So in this scenario, for instance, what you have is 1, 2, 3, 4 times the same number. So 4 times the same distance. So you need to select one, which one, randomly, whatever you calculate first, it doesn't matter. This dot is correct if you connect here, or if you connect here, or if you connect there or there. It's the same distance, so any option could be okay. It's going to be some kind of randomness in your algorithm. Up to you.
So unless there like a dot needs to be deleted because there's 5 connections, there should only be one line added per dot added?
Yes.
Cool.
Yeah, only one. You put one dot, and your algorithm should search for the other dot to make one line, only one line. Good?
Professor, I had a quick question. Referring to the diagram above, which you drew, there were two kind of hexagon that were connected, but the line you drew was not actually the shortest part. If you see the diagram, you could just connect, you can make a whole hexagon on one side and another hexagon on another side. So that is where you could come across a disconnected graph. So can you explain what needs to be done in that kind of situation?
Yeah, the only thing is the shortest path or the shortest distance between the dot that is the new with the graph. So we're only considering this new connection. Like in the example, the only thing that I am considering, the only thing that I care about is this dot is new, and I need to connect this one with the rest of the dots. So I am going to make one line, and that line is going to be the shortest one. And as we described before, we have 4 possibilities. So any of them is good. We make the connection, done. We do not consider what happened with the rest, or if there is another option in which we need to analyze all the dots. So that is not what we are doing. It's just one dot, the shortest path to connect that new dot with any of the ones that already exist in the graph. That's it.
Okay, okay.
Good. So it should be something easy. The adding a new dot, the adding a new line. That is the work of the source of knowledge. That is the work of the student that we have in the Blackboard. The work for that thread should be something easy. The only thing complex, quotation mark, is the control, the professor, and what happens when we delete something. And the idea is that the delete process should be like adding quickly 5 new dots and just connect them. So that's it. The Blackboard, the repository, composition, code. Well, remember, for the question about the Blackboard, I have that question before. Just remember, you have your Blackboard, the repository, as a singleton. So this guy can be accessed by anyone. You do not need to have control or source of knowledge like living here. A relationship like a diamond, you do not need that. That should not be correct. Remember, we talk about this. A student is not the parent or the child of the Blackboard. Also, the Blackboard is not the owner of the professor or the owner of the students. Those relationships could be kind of semantically not correct, right? What you want is this relationship in which the student uses the Blackboard or the professor uses the Blackboard, because that sounds like something that is going to happen, using, and using in that direction. The humans, student or professor, control or source of knowledge, use the Blackboard. So what you're looking for in a diagram in UML is going to be something like this. Association. Now, just because this guy is a singleton, that association is very easy to get, because the only thing that you need to do in the source code here is repository.getInstance dot and any of the methods. So pretty simple, pretty direct, just because you make singleton the repository. So your diagram is going to look something like this, the loop for the singleton, if you want to put the loop, and the arrows pointing to the repository because you are using the repository from the control, professor, and the source knowledge, the student. Okay, question about this again. As I described before, you can check the video, but basically think about you have these dots. You have a dot there, nothing happened. I click again, I have a second dot. You have only two dots, you're going to connect them. You only have to, when you click again, like here, there is a new dot. And the thing that you want to do is to connect that dot with the one that you already have. And what you're going to do is to search for the distance between this one and this one, the distance between this one and this one. And you're going to create a connection with the closest dot. So that one. And if I make a click again, and my click is like here maybe, and then I am going to connect this dot with one line with the others. Obviously, it's not going to be this one. It's the farthest distance. It's going to be one of these two. Again, maybe that one. So that is going to be your connection. If I make click again, and I make click here, the only thing that I need to do is to calculate the line to connect this new dot with the others. The shortest one is this one. So a line, and that's it. You continue in that direction. It's just only about the shortest distance between the new dot and one of the dots that already exist in the graph. That's it. So one process is doing this. A new dot, good. The shortest point, create a line. Nothing else. So you're going to get crazy pictures like this. The other process is all about checking 5 connections. So 5 connections, if I add one dot here, I am going to have this connection. Now this one have this 4. If I add another one here, very, very close, I am going to connect there. And in that point, the other process is going to start working. The other process, I have one dot with 5 connections. So remember, step number 1, the dot that have the 5 connections is going to be deleted, and all its connections. So this connection is deleted, this connection is deleted, this connection is deleted, this one, and this. So now you have this group of dots disconnected. And what you're going to do is to, again, the same process that we apply at the beginning. It's like the dots that we have, the graph that we have, the closest one. The closest one. The closest one between what I have and these dots. And it's like, well, probably the closest one is this one here with this one here. I am going to connect that one. So now my graph is those, this one, and this one. The same process again, the closest dot to the graph that I already have, maybe this one, now that one's connected. And again, the closest dot to the graph that I already have. So this one is close to the graph. They are connected. And finally, the last one, the closest one, I don't know, it could be this one. So that is my new graph. Delete the dot, delete the lines, and then the process. The closest dot to my graph, connect. The next closest dot to my graph, connect. The next closest dot to my graph, connect. And when I mention closest dot to the graph, is to any of the dots that are part of the graph, to any of the dots that are connected.
Professor, with this example, if you were to connect the dot that has been connecting to everything, and you connect it to the right dot first instead, let's assume that this rightmost dot is the closest dot to the middle one. And when you're checking the next closest dot to the rightmost path, and it's back to the middle one, so it will connect back to the middle one, I'm assuming. So then how exactly do we proceed after that? Like, then the bottom 3 dots would kind of create a triangle. because
yeah, like let me do the. I have those dots, right? It's what I have. So let me put some letters here. A, B, C, D, E, F, G. So let's say which one? Which is the shortest path?
So right now we'll say that D is the shortest path to E. So E and D connects.
Mm-hmm. Well, but the point is, remember, step number one, this is my graph. So this is what I have. Now, step number one is tell me which is the shortest path, the dot that is closest to this big picture.
Yes, Professor. Like in this example, I understand that A is closer to E. I'm just giving a situation where D is actually closer to E compared to A. That's what I'm asking. Like, let's assume that E and D are the closest points here. Let's assume that.
Okay, let's assume that D is the closest one.
Yes.
Okay, so let me just redraw this. Like, let's assume that, for instance, A, B, and C are those points.
Yeah.
So I delete these ones, and now these are in this position, and D is the closest one. Yes?
Yeah.
Okay, so in that scenario, we're going to connect D with E. And then?
Like when we're checking for the closest point to D, it's again E, which is the closest point. Let's assume in this case again that E is the closest point to D now.
Well, in this scenario, what is going to happen now is my graph, the points that I have connected are all of this. So this is my full graph. And what I am going to look is the dots. Which of the dots is the closest one to the picture, to this big picture here? So any dot of the ones that are disconnected that is closest to any of the dots in my graph. And what I am going to discover is what it looks like the closest connection that I can create between a dot that is disconnected and my graph is probably this A that looks to be the closest one to D. So the next connection that is going to happen is this D with A.
Okay.
One dot that is free with any of the dots that is already connected.
Okay. Thank you.
Okay. So just to complete, the next scenario is going to be, okay, now my graph is all of this, and I am going to search for the closest dot to the graph, and probably it's going to be B. And then I am going to do the same again, and I don't know, probably it's going to be this one with this one. So that is going to be kind of the full picture. Good. Okay, guys, so hopefully this clarified. You still have time to work on this. And remember, one common question that I receive is whether or not to use threads. And the answer is depending of the solution that you're implementing for the shortest path. If you are not implementing a particularly good algorithm for the shortest path, for the short distance, whatever, you are going to need threads, because if this process is slow, it's going to be very, very noticeable in the graphical user interface. So in that scenario, you will need to use multi-threading. You already have examples about how to do threads for student and professor for control and knowledge source. So you can make them threads. And with that, you solve the problem of this slow process of recalculating distances. That is the only tricky part. That is the only complex part. Everything else should be easy to do. Good. Okay, moving forward.
Professor, just one more thing. So for the midterm, there was a question I had a doubt with. I had contacted the TA about it, but I got no response. For the observer pattern, she had deducted 1 mark from the solution because I didn't put a set successor for some reason. But when I was reviewing the slides, I did.
Do me a favor. Forward the email with the explanation of the question, with everything, to the TA and copy to me, so I can use either check myself or ask the TA to review. Just forward me the email so I can read what is the problem, take a look, and go into the details. Good?
Okay.
In general, if you send an email to the TA and for any reason you do not receive an answer in 1 day, 24 hours, 2 days, 48 hours, forward the email, follow up in the conversation with the TA, and include me in the email so I can take a look. Good. Okay. Moving forward, I want to talk about this idea of smells in design, but also in programming. It is a concept in software engineering. It is a concept about something is not good. Something do not look correct. Sometimes you cannot be sure that something is wrong, but you are sure that something could not be okay. And could not be okay, I am talking about the quality. Something there looks like the quality could be better. Something there looks like you have a violation of the principles of object-oriented, or the patterns, or the structure. It looks like some of the principles that we have describing is not there, is missing, or is used incorrectly, or moreover, the structure. For some reason, the connections between two classes or between two packages, you notice that the connection is not following the ideas of composition, association, aggregation that we have reviewed before. It's like something is not fine, but you cannot have 100% the idea that is wrong, but it's just something do not look good. And that is the concept of smelling. Let me give you an analogy of this. If instead of software engineering, we were talking here about civil engineering, and if I told you that, you know what, you are designing a home, house, or a building, or just a room, but then I explained to you that in order to do the blueprint of the room, the home, the building, some of the elements that you can use for the blueprints are, for instance, you know what, one line represents a wall. So you can create something like a square, and that is basically 4 walls enclosing a room. You can represent a window with a symbol just like this. So for instance, if I do a draw and I put something like this here, I am representing a room enclosed with walls, but in one wall I have this window. If I told you that, I don't know, a door is something like this, use the door open and the direction of the opening, and then you draw something like what we are representing is this room with one door and one window, right? So you look at that and you say, well, that is fine. I have no idea of the dimensions of the room. I have no idea what is going to be the use of that room. But it's like, well, it has one window and it has one door. Fine. It's nothing to tell me about a mistake. But if I go back to my original example and I show you a room just like this, a square, if you are a civil engineer, you're going to notice this one and you're going to say like, something is wrong there. I don't know what is happening here, but something is wrong. And you know that something is wrong because it's like, this is a room, 4 walls, without a door to enter to that space, without a window. And probably the window is the less important thing, but we do not have a door there. There is no way to enter there. What could be the reason for having that? Again, it's not like you know that something is wrong, but you notice that and you are going to think something is smelling here, something is not correct. It could be the case that you need a room without doors and windows for some particular, very specific reason, but 90% of the time it's like, that is not going to happen, that should not happen. Similar things happen when you look at the diagram for software. You cannot be sure that something is wrong, but you're going to notice like something here do not looks fine. Something here smells. Something. Martin Flower, if you want to read the book, a very good reading for you if you're involved in the software engineering thing. Design smell, code smelling. I am going to talk about this one, and I am going to use some diagrams. So what could be wrong? What are the things that we can detect? Like, this is not exactly good. It should be something related with abstraction. Abstraction, in particular, a lot of inheritance or not inheritance at all. It could be something about encapsulation, a lot of methods, variables, or not methods and variables at all. So I am talking about a lot of things inside or a lot of things outside. Modularization, something that we have been talking a lot is this idea of separation of work. If you have a software and that software has several different responsibilities, somehow we are expecting to look at the diagram and notice in the diagram these kind of different places in which different things are happening and they are connected. It's like a small city in which you have this place in which you have a particular function, like everything regarding the graphical user interfaces is here, but then everything related with the data is here, and everything related with some fancy calculations, algorithms, artificial intelligence is here, and so on. It's like this small city with small parts in which something is happening. And yes, they are connected, but you notice the separation. Hierarchy, obviously, inheritance, we need to talk about the details. And something in particular that is going to be a flag is the loops. When you have loops in a diagram, that is a concern. We didn't explore the details of the loops, but at least we talk about the loops inside of the same class, the singleton pattern, at least. There are classes in which it's okay to have loops, but sometimes in some classes, in some places, it's going to be a red flag. It's going to be a smell. Rules for your diagrams, for your projects. Guys, it is very common that we want to show a diagram that is complex. We want to show a diagram that is full of connections and full of elements, just because we think that showing something complex, something this a lot of elements with a lot of connections, with multiple lines crossing, show that we are very good engineers because we are able to do that thing that is very, very complex. That is not true. When you show something very, very complex, when you show something that is hard to understand, it's more like a lack of skills than, wow, this is the best engineer ever. When you do a diagram, it's like when you write a paper. It's not about the size. It's not about making the reader think that you are so smart that the reader cannot understand you. It's the opposite. If you are really smart, if you are really good, you can put that knowledge in make the solution simple. And simple is easy to read, and in a diagram, easy to understand what is happening. It's like you are the teacher, you are the instructor. Your goal is not to show that you are good, but to make the reader understand whatever you are sharing. In this case, the solution for your software. So it is not about you, the diagram. Keys, keep it simple, dry, do not repeat things. Those things, we review them for the source code. They apply the same for the diagrams. Exactly the same. Semantic, just as I described before, we cannot talk about inheritance between a blackboard and a student just because semantically do not make sense. And something that you want to do with the software is to represent things that happen in the real world, because that is going to make easy to understand for the people. What are you doing? And if you show a solution in which, for some reason, a blackboard or a whiteboard is the parent of a student, or if you have this solution in which a blackboard, the whiteboard, is the owner of a student, those things do not make sense semantically. On the opposite, if you represent that a student is using a computer or is using a blackboard, that makes sense. Makes sense in the real world, and it's going to make sense in your software. It's going to be easy to read. Easy. This one probably is the most important one. When you submit a diagram, it's not about doing a draw, and that draw is just a decoration for your source code. Really, the diagram should match the code. And we have been talking about this a lot, and I want to show you some examples, even now that we're almost done with the class. If you do not match your source code with your diagram, the diagram is just useless. Again, if you have a blueprint of your home, and the blueprint is showing you 10 rooms, but your home only have 2 or 3, it's like, what is the reason for having this blueprint that do not match with what I have in the reality? Similar with the software. So I am sure that all these things that I mentioned, we reviewed before. We have been talking about this in the previous 14 weeks. So I am sure that you are using this in your work, in your assignments, in the one that you're going to submit this week also. Just to be sure. Some diagrams from your previous assignment, some diagrams that some of you submit, and I want to ask for your help with the grading. I want to ask you, these diagrams are good, or there is something there that maybe smell, right? Something that do not look good. The reason because we use the term smells is like, I am not reviewing the source code. The only thing that we're reviewing is the picture, the blueprint. And with the blueprint, I cannot tell you 100% that this is wrong, but I can assume that something is not okay. It's not okay maybe only in the diagram, or it's not okay in the source code. That is a different story, but something is not okay. So this diagram, I want to show you this one, a zoom in these 2 rectangles. So just giving you a perspective. This is the diagram, and I am going to show you this space and this space, and ask you for your help about the smells. First one, the top one. Did you notice something here that could be a smell? Something here that could be not exactly okay? There are several things, but yes, one of them is connected with observer and observable. 2 things. I am going to talk about the panel, but yes, it's also another one. Let's see quickly. If you're grading this, number 1, do you need to put this connection? The connection between 2 classes from the library, in this case, observable and observer. And something that we reviewed before, you do not need to put that line. Okay, number one. Number two, did you notice that this class here is observable? Okay. And did you notice that the main here is observer? And there is a question. Can you help me? What could be the reason for having the class that contain the main as an observer? What is the responsibility of the class that have the main? There is any reason for having that one being observer? It's going to be doing something? Something what? Is a good separation of concerns? Yes, no, maybe. Something that we reviewed before is, okay, I agree with that, not. To note. Do you remember that something that we review is the class that have the main, usually the responsibilities, that class is the boss, and the only thing that that class is going to do is to create others and put those others to work. Main is the leader, the boss, is the one that is going to create these workers, is going to connect them, and is going to ask them to do some particular task, and that's it. If you put the main as an observer, you're including the leader as part of the working process, and that is not particularly a good idea. And if you read the chat, I fully agree with that. That is the task of the main, delegate functions. So when you have this, with the class that have the main, that is a smell. It's like, the main should not do that. Separation of concerns. Something is not fine there. Either it's an error in the diagram. Maybe this relationship is in the diagram, but it's not in the source code. It's a problem about the point number 6. The code and the diagram are not matching. But if this is also in the source code, what we have is a problem with separation of concerns. Both the scenarios, there is a smell here. There is a problem. Something is not okay. Anyway, the other. A panel, a text area, a menu bar, some widgets. These two, according with this diamond, they are global variables. The first thing that you're going to think is, why global? They could be local, but what? They are global. Fine. Do you remember that either you put the variable as an attribute or you put the relationship, but not both? Two things. We talk about that, right? That is not correct in a diagram. You have been doing several diagrams, and well, that is something that you receive feedback. You should not do that. Again, do not repeat the representation. You can represent the relationship, fine, that is good. You can represent the text, the attribute, not both. Be careful. Okay, so far, moving forward. You can review that. The other part of the diagram, remember, big diagram, the other box. If you review this, anything here that you can make some kind of comments, anything here that catch your attention about what happened here? Similar problem that before, the relationship versus the text. Yeah. Something else. Are these okay? The names. Now remember, in a class diagram, you put the name of the class, shape, maybe. Not sure what is this. Maybe there is a white space there. Hopefully use find transform. Be careful with the names. What is going to do that class? What is that class? Is one class? But well, the most important maybe, again, attributes versus relationships. Use one, only one. You have three classes, triangles, rectangles, lines. There are similarities between them. It's a common example when you learn to program. A rectangle, a triangle, they have dots, the lines also. Sometimes what you do, a common example is to have a parent for them, a parent that basically represents the shape with the common variables or the common methods, and with that common parent, then you move forward to do the specifics, but a different story. Probably you can eliminate some of the attributes here, moving them to a common parent. That could be a recommendation. A different example. This is a full solution of your project 4. What do you think about it? Okay, one of the common things that you are going to use for smells is the diamonds. Remember, the diamonds imply a strong connection, any of the diamonds. Something that you're going to review when you look to a blueprint is whether or not diamonds are needed, because diamonds are a strong connection. So every single diamond that you have there is like something that is going to complicate the testing. It is not bad to have diamonds. Sometimes you need diamonds. You should use diamonds. The problem is you cannot use diamonds for everything. It's a bad idea. You need to prioritize association instead of aggregation or composition, something that we reviewed before. So the first thing here that is going to catch your attention is the diamonds are kind of in everywhere. Something that could be refactored, something that can be improved. Again, we need to review if the diagram really matches with the source code. And if that is the case, something that you can do is a lot of refactoring to reduce the coupling. But talking about diamonds, something that is going to catch your attention in particular, because remember, we start reviewing the diagrams, searching for the main. The main is kind of the first space in which you are going to look at. And then from that point, you're going to move to the rest, right? It's just one approach. So did you notice where is the main here? And then I am going to talk about that one, class diagram and point. But did you notice those two relationships there? Main has graphical user interface. Your graphical user interface has the main. What do you think about that? Suspicious, exactly. Suspicious, again, recommendation number one could be to use inheritance directly with main. Main is not doing anything, so main could be your graphical user interface. But well, if you want to have the graphical user interface in a different class, like this frame in a class graphical user interface, that is fine also. But this connection here is suspicious. Why the graphical user interface would like to access the main? It's like, again, the main is the leader. The main is going to create all the different actors. One of those actors is going to be the graphical user interface. And that's it. I mean, graphical user interface, go to work. Why should the graphical user interface have the main back? That relationship, for sure, can be refactored. For sure, is pointing to something that is not okay. So, a problem. The graphical user interface have this connection here. The graphical user interface have this connection here. And you have this connection here. What do you think about this part? The using from GUI to this one, and the having, and the having. Something that we didn't review before, I want to bring the topic right now, is layers. Usually, if I am the owner of something, and this something is the owner of this something, think about hierarchical relationships. I am the boss of this guy, and this guy is the boss of this guy. So we have this, I am the top, this is my employee, but him, this one, is the boss of this one. And something that you do not do is that this guy, even though he's the top in the hierarchy, communicate directly with this guy. That is a mistake, right? That can create problems. If you are the top guy, you're going to communicate with the guy that you have below, and that one is going to communicate with the one that is below. A line. And that is the line that you create here. If you are the owner of this one, you can use this one. And if this one needs to communicate with the other, to use that other, it's going to be a communication here. And that communication is already covered with the diamonds. When you have this extra, like jumping the middle point, that is a smell. Something is suspicious. Think about it. The president of the university do not have direct communication with the teachers. There is a line there. And if you jump the line, something is not working. What is the reason of having the line if you're just going to jump? I smell. Now, okay, I have this graphical user interface with some elements. I have this parser with some elements. So far, something that you could be okay, and it's like a happy face, is looks like the main split one responsibility, that is the compilation, and another responsibility, that is drawing the diagrams. So in that scenario, like, okay, this is going to work. But then, what do you think about the connection between these two classes with this one? class panel, method panel, both connected with method block. Again, you need to review source code. Maybe this is working, but semantically speaking, why this one is connected between class panel and method block? Why is not connected with class block? Because if I have these two, this one is the owner of this one, could not be used enough to connect this one? Do we really need two connections? Okay, if we need two connections, what is happening with this guy? Now, if the connection should happen with both, why not connect with the parent? Or why not to have a common one above? I am not telling you that something is wrong. I am telling you that all these connections is the ones that the TA is going to review in the source code, because we are very curious about, this is really working? Everything that is in this diagram is used like this, looks suspicious. What do you think about this connection here? Parser is the owner of connection, which is the owner of classes, but also parser is the owner of classes. It's a loop, remember? The loops is something that you always want to review. I have a loop here. Moreover, I have a loop with diamonds. Do I really need that? The first rule is, if you have loops, you need to think about refactoring. If that is not possible to refactor, there should be a very good reason for having this. A semantic reason? Not really. I mean, I understand that connection is something that we need, but probably could be deleted if you want to have parser with all the three different elements, connections, classes, methods. Those two, one is inside of the other, probably should be connected different. Again, it could be fine, but this raises suspicious about, really the source code is working in this way? We're going to review. Anyway, some ideas. Another one. What do you think about this diagram? Again, we're searching for things that could be better or could be wrong. What do you think? Are you able to find the main? Is the main correct? Any problem with the main? I start there and the static is missing. Yeah. Okay, the static is missing. I put the underline, now it's static. The main have the listeners. This is important. The main is also the listener. Okay, no problem. The main is going to have the listeners. The main is the one that have the frame. Okay, the main is going to be the graphical user interface. All these diamonds are suspicious. All those diamonds can be used associations. They do not need to be diamonds, but okay, it's just something that can be refactored. And then the other connections. The other connections is with Lexer and with Bridge. Those two are the real connections between the graphical user interface and the actions that are going to happen in the program. This one, the one with the Lexer, makes sense. It's going to be the first thing that happens when you do compilation. You are going to call the Lexer, even though now it's not a Lexer, it's more Lexer with the parser, a compiler. But well, it's going to call the Lexer. Okay, the Lexer is connected with nodes. Okay, so the Lexer is going to have a collection of nodes, which could make sense. Okay, the node have this bridge. Okay, and did you notice that we just create a loop here? The main is connected with bridge and Lexer, and then somehow Lexer is also connected with bridge. We have a loop. A problem with the loop? Always, 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 when you have loops, check what is happening there. Check if you can do it different. Bridge. The loop is something that catches your attention. The thing in which you are going to be concerned is, okay, what is this bridge? Bridge is drawing a figure. Bridge have a connection with circle. Bridge have a connection with rectangle. Bridge have a connection with triangle. Bridge have a connection with line. Do you think that you can replace all these connections with something else? Again, I do not know what is happening. What is the goal of that? However, when you look at connection of using circle, using rectangle, using triangle, using line, there is something that you can do to make this clean, a good principle in object-oriented. Moreover, you notice that all of them inherit from a particular class. What is the solution here? To remove all this and change all of them with one line. Do you remember polymorphism? They are already childs for this one. Can we have used this one there? Using the base? I don't know. Again, this smell concept looks like something could be improved. Looks like if we remember polymorphic behavior and we use the parent can replace all of the childs. If you remember the design patterns, usually the patterns are connected with the class at the top, the parent. That is the reason because we define a parent. We already have a parent here. Do we want to use the parent? I don't know. It's something that you can check. I smell. Yep. Now, this one, change that one. Something that I do not know if it's missing using the diagram or maybe in the system is, did you notice that all the childs of this class are being used by bridge, except this one? I mean, in the diagram, I noticed that that one is a child, but no one is using that one. And because the parent is also not being used, my perception is that that one combined figure is not being used at all. I don't know. Two ideas. This project is not complete, or if the project is complete, maybe something is missing in the diagram for you to review. This one. What do you think about this one? Hopefully you can read things. This here is Lexer. Lexer is observable. That is good. This is an observer. This observer is connected with this class identification. This is main. This is JFrame. And this is listener. Question. This main is correct. Yes or no? That may have the listeners. So is correct, or something is missing with the main. Something is missing. What? Tell me. The main is the one that is going to trigger the actions. The main is the one that is going to trigger the lexer or the parser or the drawing things, right? Just because the main is acting as a graphical user interface and also as a listener. So when the user click on the menu, the main is the one that is going to receive that notification. And therefore the main is the one that needs to put the things to work. When you read this diagram and you notice that the main is not connected with any other class, use the lexer. That is the only thing that the main is going to do, call the lexer. Makes sense? Now, it's going to call the lexer. It's a JFrame. It's a listener. Okay, moving forward. This lexer is going to use this notification for something. It's going to call a method. That identification for something is going to call this shape. Something is going to happen. Ouch. Shape is a J-frame. What do you think? This is a J-frame, this is another J-frame. Makes sense? No. Maybe you want a panel? It is not mandatory, but okay, maybe you want the panel. Now, shape is use the shape, or shape is your working space. I don't know. But here we start with the question mark. Is why shape the frame? Okay, maybe the name, maybe the working space, and then could make sense this diamond having things that are drawable. Could be that one could be assumed is an interface because of these connections. But then, what do you think about this? Semantic. I am reading here drawable. I am reading here draw line, draw rectangle, and draw circle. The smell here is, maybe you want to represent this. Maybe you want to represent realization, because this one is realization. This one is dependency. And we know the difference, right? In terms of the source code. Yes or no? Big question. Now, this is one diagram, and this is another one. Both represent the same system. Do you think that this diagram is complete? Do you think that if we go and review the source code, all the connections here are all the connections present in the source code, assuming that the source code is solving the problem? Because if yes, compare this one with this one, the number of lines, or with the others. You need to review source code. However, I agree with the chat. The smell here, the thing that you're going to assume because you know the problem, you solve the problem. It's like, you know what? Everything seems clean. Everything seems too perfect. That probably is not correct. Really, guys, you look at this, it's like everything looks so perfect, except these lines that maybe are these lines. Something is missing. Because the problem is not so simple. Because you need a lot of connection between the data and the graphical user interface. And I don't know, maybe the solution in the source code is really so perfect, and this will be an A+ solution. I don't know. But the first thing that you're going to think about is, I want to review this in more detail. Because if it's so perfect, yes, I want to put the A+, but maybe things are missing. What do you think about this one? One point that is going to make you think that this is wrong, not just smelling, but wrong. One thing. Can you detect what is wrong inside of that circle? That for sure is not going to be in your source code. Well, the line here is missing, but something wrong. Do we understand that relationship? What are we saying there? Can you agree that that line is telling you that panel have inside a main? And can we agree that that is not true? Not possible. Yeah. Smells. Things that like something is not fine. Did you notice the size of this solution? And you can compare with the size of this one or the previous ones. Do you think that is complete? If you are the grader, you're going to take special attention on these ones because something is missing. We need to see what happened. Anyway, I am sharing with you more diagrams, more diagrams, more diagrams, more diagrams, more diagrams, more diagrams, more diagrams. And in all of them, I have detected the smells. In all of them, they have an issue that is easy to notice. My homework for you, because I do not have more time to review every single one of them. But if your diagram is here, or even if it's not yours, just practice for your exam. Look at the diagram and check if you can detect the error. It's just like that. This picture have a problem. Can you detect the problem? And after 14 weeks that we have been working with this, hopefully you can do it, either yours or not. But it's something that you're going to do in your exam. We have the exam next week, by the way. But this is something that I am giving you like practice for your exam. We can talk more about this in the review. Hopefully, if you have questions about these diagrams, we can talk about it during the review. You can send me an email also. But all these diagrams have an issue. Try to detect the issue. Moreover, do not make the same mistakes in the submission that you are doing this week. So hopefully this helps you to make a better diagram for this week homework. Good? Okay, guys, I am going to stop here. See you next lecture. Thank you.